All right, my friends, welcome back to another episode of the Build Show podcast. That's right, my weekly time to get together with you guys and go deep. We're doing a part 2 today in the podcast. Sean Harris and I just spent some time talking about new construction, indoor air quality, mold prevention, specs. Boy, Sean dropped a standard for me on pre-filtering for an ERV that blew my mind. We're actually going to maybe jump into an additional portion on that I missed on the last episode. So if you haven't watched or listened to that podcast, you might listen to that first before you get here. But on this particular episode, we're going to talk about existing homes, houses that are 5, 10, 30 years old. What do we do, especially thinking about remodeling, to get better indoor air quality? How do we make sure that we don't get mold in these houses that are older houses? Or if we find it, what's the scope of maybe remodel that needs to happen? This is going to be a really good episode. Sean's a fabulous guest, and I'm really thankful to have him here. With that being said, from the Rockwell Studios in Austin, Texas, let's get going. Guys, before we jump into Sean Harris today on this topic of mold in existing homes, prevention and remodels, I want to say a big thanks to our podcast sponsor, Embrico. This is a really interesting company. They basically make tile decks. And when I visited these guys, a couple things that are really interesting about this company. First off, this is a builder who invented a product and then didn't see a way to bring it to market without starting a company. So this is cool. This is a builder who found a solution to a problem he had. And what the product is it's basically a ceramic tile that installs over top of a standard wood deck so that you can get a basically fireproof, very long lasting, zero maintenance. Also, no issues with frost or freezing because it's ceramic, so it doesn't actually absorb anything. And now I can get a deck surface that acts really like a patio, except it's drainable. Fabulous product. Very, very interesting. Go check out my videos that I made with these guys. But if you have a project that you're interested in, I highly recommend you give them a call. Very personal service, family owned small business. The dad and the son are running the company. So the times that I visited with them, I could tell like these guys are super involved with the business. They can give you a quote. They can send you samples. Really, really interesting company. So thank you, Embrico, for sponsoring. Go check out their website for more information. Sean, thanks for staying for part 2 on this topic. I want to switch gears on this podcast. Hopefully people listen to our previous one. On the last one, we really talked new construction. On this one, we're going to talk existing homes. And if for some reason someone doesn't know you, let's establish your bona fides for a minute here. You and I go back at least 20 years or so since when I first started my home building company here in Austin. You've been doing indoor air quality testing. You've been doing blower door tests. You've been doing duct blasts. You've been doing pre-sheetrock inspections for HVAC systems. But you've also, in the last 10 or 15 years, really spent a lot of time helping people that have issues with IAQ in their existing homes.
Definitely.
And so what I'm hoping to extract from your brain today is a little bit of advice for people that are maybe worried about it. Also, specifically, let's think about, hey, if we're going to remodel my existing home, what are some things that I can do in this remodel to make sure that I'm going to both prevent and cure potentially any issues that I've had in the past with moisture, with mold, with indoor air quality. It's a big topic, and I purposely didn't have you think about too much of this ahead of time because I really wanted your off-the-cuff thoughts. Yeah. So first off, let's start with the idea of houses around Austin that you're pretty familiar with, which I think is a good slice of the country. What do you think the scope of the problem is in terms of indoor air quality with houses?
Yeah, so just real quick to back up, my passion is improving people's indoor air quality, and my experience with building science consulting has really sort of led me to that. And I've been able to help quite a few sick people. One of the services I offer is indoor air quality consulting, where I help people navigate what to do if they feel their home is making them sick, and where to look and what to do with the things, what to do with the materials, how to build back if we're going to build back. Yeah. So that's a lot of what I do here. And as I mentioned in the last episode, in 2024, I was in 140 homes, specifically helping people navigate this process, because it's really overwhelming. If you feel like your home is making you sick, it's hard to know where to go. The threat is invisible. So it also doesn't affect everyone. Sometimes the husband is totally fine and thinks that the wife is just all in their head. And it's very frustrating for people to have to deal with this. And so I feel very thankful that I'm in a position to help people in this way.
And I think the reason why you're in that position, if I can talk about you in front of you, is you have a really good building science background. You understand the science of what affects houses. But I think the other thing that's so different about you than some other folks that talk about this issue is you've been in a lot of homes. You're not just a mom or a dad who had a sick kid and has researched it. You've been in the industry doing blower door tests on new construction, on old construction, looking at duct leakage. By the way, Sean also owns the Air Barrier and Aero Seal dealership here in Austin. So you've corrected these issues. You've literally been in thousands of homes over your career. And so I think that makes you very different than a lot of folks that call themselves experts in this topic.
Thank you, Matt. I appreciate that. Yeah, I definitely feel like my custom set of experiences has really led me to where I am, and it differentiates myself from a mold inspector who's only looking at mold, or an HVAC person who is only looking at selling HVAC units and not really looking at whole home solutions and things.
That's right. So then let's talk about problems that you find in existing homes and commonalities for those problems.
Yeah. So first, we can definitely talk about the broad scope of problems across America, but right now we'll focus specifically on hot, humid climates. So we're in climate zone 2A, hot, humid, similar to Florida. Even though we're in Austin, Houston is a little more humid, but it's pretty much the same from a climate perspective, pretty similar. And the climate zones are continuing to move further and further north. Unfortunately, we're getting more and more humid further north in Texas as well.
Interesting.
So what I seem to find in this area, spanning from, probably Waco down to Houston is sort of the general area that I service, is mold inside ductwork a lot of the time, and typically one other source of mold someplace else in the home as well.
Interesting.
But basically, when we live in a hot, humid climate, we have ductwork that's done in unconditioned space, or we have humidity problems in a conditioned envelope like a spray foamed house or something like that. And one of those two things means that the coldest surface in your home is going to be wet when we're talking about humid climates.
Yeah. So when I first moved to Texas, here's a quick story. I moved here in 2005, and I'd lived northeast and I'd lived northwest. I'd never really lived in a hot, humid climate before. I always mainly lived in either mixed or cold climates. And a funny story, the first Halloween I moved here, I said to my wife, hey, it's October 1st, we should carve our pumpkin. She's like, no, I don't think that's a good idea. For some reason, I always remember growing up carving my pumpkin like 2 days before Halloween. I was like, no, come on, let's do it. So here we carve our pumpkin October 1st, and within a week, it was a moldy mess on the front porch, right? Because it was probably 80 degrees and sunny a couple days, and it probably rained for a day or two, and we had humidity in the 80s, and it was just a pile of moldy mush growing out. And I use these photos on my talks a lot to say, like, it was a wake up call for me to go, wow, I'm not in Kansas anymore, so to speak.
Definitely. So our bodies aren't quite as fine tuned with humidity as they are with temperature. So we can notice a 1 or 2 degree temperature swing pretty readily. Some people are even more sensitive than that. But when it comes to humidity, you're looking at 20% swings before you really notice that there's a difference. And so while it may not feel like it, we live in a very extreme climate with 80 degree dew points outside, which is intense, and we just don't quite realize how intense that is for the materials we're exposing that to. I have a neighbor right across the street from me who just moved here from California, and I haven't told them this yet, but every night I look over and all their windows are open inside the house, and I'm like, you can do that in California, you can't do that here. And so I'm going to have some sort of talk with them, I think, because that's concerning.
I'm surprised they didn't close them when they realized that every surface condensed the other day. Like I went to the gym, forget what day it was this week, and it was a weird temperature swing where we went from real cold for a couple of days to kind of warm. So every surface in this gym that's an unconditioned gym was cold. They swung open the doors on a day that changed, and it was really humid out, and the barbells, the floor was slippery. Everything had condensation on it. So we just have to be a little cautious in this market. But I also want to focus on houses throughout the U.S., not just Texas, Sean. When we think about houses in cold climates, what are some of the issues that you see out there in other climates besides hot, humid?
Yeah, so in other climates, we still have mold to deal with there too, with water leaks and things like that. It's a little less prevalent, I feel like, than it is here. But the other things about indoor air quality, there's so many other things to talk about. I mean, each one of these topics could be its own podcast. But we've got radon. Radon in other parts of the country is a lot more prevalent. We've got particulate matter PM 2.5 that is a problem, and that encompasses all sorts of different materials and things like that. We've got VOCs, so chemicals from whatever it might be. I mean, the first thing I think of is like fragrances, right? So like your air freshener that's in your car or the plug-in ones in your house. Those are endocrine system disrupting chemicals that we're putting into the air. And what that means, your endocrine system is basically everything about your body's management, your mood, your hormone production, how you feel that day, how much you eat, all of these things come back to this endocrine system that really controls all these bodily functions. And when we put these air fresheners in place, we are disrupting the balance of that, both by blocking how the endocrine system works and by imitating other things. Like there's estrogen imitating fragrances that basically stop you from producing certain hormones. And now you've got depression, anxiety, you've got headaches, you've got all these other things that can happen that you don't quite understand. It's this invisible thing that we're exposing ourselves to. So.
And it's crazy how prevalent that is too, Sean. As a side note, Corbett Lunsford, if you know him, did a series of videos through some University of Texas testing. I think they called it Home Chem.
And great.
It was really fabulous series of videos. But the big takeaway I got was if it smells like something it shouldn't smell like, it's probably bad for you. So for instance, the scented trash bags that my wife was buying because she didn't like the smell of trash. She wanted lavender. I convinced her to stop buying them. But it was hard to do. Like, she's like, no, I really want the lavender scented ones. And I had to show her the science behind,
so
hey, here's why this is bad.
There was a study done with young women exposed to lavender essential oils who ended up getting premature breast development, where basically, lavender exposure is not a great thing.
For us.
Yeah, exactly. So not to say everything is bad for us. In a sense, I guess everything is bad for us, but we shouldn't be extremist about this. I don't want to come across saying like, don't do anything. My opinion here is like everything in moderation. And the more we know about things, the more we can limit certain exposures because it's unnecessary too. So
and I think it really just boils down to if it smells unnatural, it's probably not good for you. Like that new car fresh smell that I remember from the 90s when my dad got a new Toyota. That was not good for us. And so once you aired out the car for a period of time, it would be fine. And the same is true in a lot of ways with new construction, right? We got a lot of smells in new construction. That fresh paint smell is not good for you. So air out the house. And folks that have more chemical sensitivities know today, hey, I need to not move in the day it's finished and I get a certificate of occupancy. I need to throw open the windows as much as possible. I need to run my ventilation system. And, for instance, I have a client that is very sensitive. They waited 2 months on that house. They tried to throw open the windows on any day that had lower humidity. And in the meantime, they ran their Zender system on high. And then when they did move in, they felt great. So, there is some science behind this, but there's also, frankly, just some common sense.
Definitely.
That's involved in that as well. Let's talk about remodels. One thing that I wanted to ask you about that I get a lot of is, I want to remodel my house to get rid of my ducts outside of conditioned space.
Oh, nice.
I live in a 1970s or 80s or 90s house in Texas. My ducts are up in the attic. I know that's a bad system. Should I retrofit my house and let's say put spray foam in my attic and bring those ducts into the kitchen space? Or should I do what I've kind of coined insulation 2.0, which is suck out all my insulation, really do a good job air sealing the lid, maybe replace what ductwork needs to be, maybe figure out a way to move my air handler into the conditioned space so at least that part is not out exposed to humidity. What do you think about those two options? Have you seen much of that done?
So those are great. I'm going to say a set of solutions that is just one set of solutions. It's not necessarily all of the solutions out there.
Sure.
But everything that you mentioned is great. The first thing I thought of and where I thought you were going to go with this is external insulation on your roof. Let's say that it's time for a new shingle roof or whatever it is.
Yep.
Putting insulation out there is a whole lot better than spray foam on the inside.
Great point.
And so being able to get your insulation where it needs to be in your ductwork and conditioned space without spray foam would be amazing.
Yeah.
There aren't very many people who can pull it off, you being one of the people who can.
Yeah.
But yeah, so that would be challenging, but really awesome to be able to get everything in that way. When it comes to getting ductwork into conditioned space, we definitely want to consider that. We need to consider HVAC sizing when we're going to change where the insulation level is, to now a lot more insulation or better insulation that now it's inside. Mm-hmm. It means that your unit is going to be oversized, even more so than it probably already was. So we need to take that into account, because if our unit isn't running, it's not doing the other things it needs to do. We could lead to more comfort issues as well. Oversizing systems also has its own set of problems. So definitely be considering those things. Typically, when I go into a home, here are people, and I'm just going to talk to normal people for a second, if that makes sense, because the people who are up against these problems where they are forced to remodel their home because of mold making them sick, they don't have an abundance of money. Right. It's not a time where they can go, oh, look, we weren't planning this, but let's go ahead and spend $100,000 on a remodel. Right. Like, they already have medical bills. They have brain fog that prevents them from working as much. They're in a tough place. Mm-hmm. And so from that perspective, I'm already recommending $20,000 to $30,000 worth of HVAC upgrades. Right. And it's really tough for me to get them to do the other things that need doing. And so for me, it's like, what are the priorities here? What really needs to be done, and what can maybe not be done because there just simply isn't the budget for it. Right. And so from that perspective, for me, it's hard because I know from a building science perspective that source control is the best. Mm-hmm. And if we can suck out all that insulation, seal all the top plates, now we're reducing our exposure this way from the contaminants that might be in the attic, but also from the humidity that's coming in. That would be really great. But very often, while that's a recommendation, it's not as strong as replace your moldy ductwork, put in a ventilating dehumidifier, and manage your humidity going forward. Remove all of the other mold that's in the space. Those are the things that I really try and focus on, unfortunately.
Well, you're optimizing rather than maximizing.
Right. Optimization is a great word for it. I like it.
Which I came across that the other day. Ted Benson was using this term with what he does, where we've got to bring the cost down so that more and more people can afford high performance. Yeah. So we can't always go for the maximizing, which my house is an example of maximizing. Like there wasn't much that I was like, oh, I can't afford that, or I shouldn't do that when it came to building science or a good envelope or whatever. Like I really maximized my house. Yeah. But then the other house that I've got under construction called the Reisinger build, I think you've been over there.
I have, yeah.
We really tried to more optimize that house. Now, is it cheaply done? No, but it's not as expensive as my house. So, we used 2 pretty off-the-shelf ERVs from Life Breath. We used 2 pretty off-the-shelf dehumidifiers and from Santa Fe in the house. We used 2 pretty basic carrier systems. And I actually went to RIA ducts for part of the house, which are pretty inexpensive compared to a true sheet metal plenum that our friends at Airite have installed for me for years. So I really tried to go for that optimized. And it's interesting to hear you say that, coming back to my original question, which is, should we put our insulation at the outer envelope of the attic? Yes. And ideally, maybe even rooftop, rigid insulation, no spray foam in the envelope. That's the maximize. But the optimize is insulation 2.0, which is suck out what we got, air seal everything at that sheetrock to attic connection, put new ductwork in. Besides new ductwork, what are you also recommending typically on those houses? Are you trying to move their air handler inside? So are you adding additional filtration? What else are you trying to do?
So very often the house was not designed to have the air handler inside. Very often, unfortunately, it's also a gas furnace. And so especially the 80% furnaces, it actually makes more mold. You put it into a closet now, and now you've got more cold surfaces around it. You still have to vent it to the outside because it's an 80%. And now you make more mold in this mechanical closet.
Totally.
So So it's not, and I often, people ask about it and I'm like, yeah, no, don't put your 80% furnace into a closet in your house, unfortunately. So often it gets left in the attic where we're making ice in an oven, and that's not great, but the oven provides some drying on
making
those.
Ice in an oven, I've never heard that before.
Yeah. So often I am just sort of trying to do the best with what we have. And so making sure that the ductwork is properly sized is super important. So when we are replacing the moldy sections, we are making sure it's sized right or even oversized a little bit, because we're about to also introduce a dehumidifier, and that dehumidifier into that supply plenum needs low static. And so we want a properly designed supply plenum that's going to have low static to allow that air to come in, because we can have all the things and check the boxes that we did things, but did we really do them well? Did we really install them correctly where they're actually functioning and efficiently removing moisture? So
how do you prevent backdrafting? In other words, like when the furnace fan kicks on, if your dehumidifier is connected to your supply side, how do you make that air not go back into and push through the dehumidifier? So
primary way for that is a backdraft damper. And, in my consulting, in my reports, it is all spelled out, because quite frankly, most people are unfamiliar with how to properly install dehumidifiers. Yeah. And so a spring-loaded backdraft damper is the first step, or a actual electronic backdraft damper that senses the signal that the dehu is running and opens the damper or closes it. So one of those two would be the way to go. And then the second thing that I put in that's a little more custom, and I again have this very well detailed in my reports, is a scoop inside the supply plenum that basically directs the air down the plenum as opposed to back through the coil, so that when the air comes out, it wants to go down the ductwork. It doesn't want to go back to the coil that direction. In my own personal house, I have a zoned system upstairs and down. So I have one dehumidifier with a Y to each zone. Oh, really? And I measured the amount of air getting sucked into my dehu return, and then I went and measured all of the airflows around my house, and it didn't add up to the air that I wanted. And I'm like, where did the airflow go? So I measured my returns, and sure enough, it's coming out my returns in some capacity. And that's why I'm like, okay, we need to really direct the air to go that direction as opposed to everywhere. So.
Of course, you also have access to a bolometer. Is that the right term?
Yes, sir.
So not everybody has a bolometer. Isn't that like a super expensive tool?
It's roughly $2,500, and it's just to measure this invisible fluid that we're immersed in all the time. That I feel like most people in this industry should have, but unfortunately don't. But yeah, it's nice tool to have.
Man, I've seen you use it on the job, and it's amazing that it can measure such small amounts of airflow, and also do it at such a high level of precision. It makes sense that it's a $2,500 tool.
Yeah.
And it feels like it's a little sensitive too. Like you wouldn't want to have that fall off the back of your truck. That little tiny fan in there is probably easy to break.
Yeah, it needs to be recalibrated every couple of years. So yeah, definitely.
That's good advice. Okay, so then talk to me about filtration. What do you recommend for filtration out there as kind of a optimize and maybe a maximize?
Definitely. So what I recommend to people at a minimum is MERV 13 filtration. And when I say at a minimum, I mean these people have mold issues already. We don't want those mold issues coming back. They have health issues. So at the filter, at the air handler itself, MERV 13, and often the April airs can't accommodate that. If we've got a 510 unit, we can go up to that 28 by 31 inch April air. That's like the largest filter. It's huge. We need that because, again, we need to keep static pressure low to prevent cold surfaces and keep everything functioning optimally. So that's what I want at the air handler. However, in our hot, humid climate, we don't want to leave our fan running all the time on our air handler with our ductwork in conditioned space, in unconditioned space.
Yes. So actually, before you move on, you and I agree on that, but tell us why, because not everybody knows why we don't want fan on all the time. Because you would think, fan on makes a lot of sense. I'm going to continuously filter out with my MERV 13. But what's the problem with fan on all the time?
So in a hot, humid climate, we have duct leakage that happens, and this duct leakage happens into unconditioned space. And we have different types of duct leakage: return side duct leakage, equipment duct leakage, and supply side duct leakage. And the return side, if we don't have a media filter at the unit, we just have filters at the grills, the return side air always is now sucking attic air into the home. and it's unfiltered attic air that's humid. And we don't have the air conditioning coil on at this point to get rid of that humidity. We're just bringing in lots of humidity from our attic. The supply side duct leakage, while that is happening, we've got airflow going out into our attic. So while the AC is running, we're air conditioning our unconditioned attic at this point. Yeah. But for every bit of airflow that goes out of a structure, out of the duct system, the return needs that amount of air back. So from a duct leakage perspective, let's say it's a 5-ton unit, 2,000 CFM we're supposed to go through. We have 20% duct leakage, 15% of it is on the supply side. So 200 to 300 CFM, cubic feet of air basketballs a minute, going out of the supply. But we know that the return is getting roughly 2,000 CFM back. Our home ends up in a deficit where we're supplying air to replace the attic that we're not actually getting back. And when that happens, our homes depressurize. So that 300 CFM that's going out into your attic is actually also now coming in through your wall cavity and causing now more humidity inside your wall assembly and inside the home.
Not good.
So yeah, not good. So unfortunately.
And the other thing too that a lot of people don't realize is, especially with an oversized HVAC system, that coil gets cold and cools down the air over the course of, let's say, 10 minutes. But there's not a lot of water dripping off the coil until before the temperature is satisfied and the unit turns off. And with this fan on setting,
reintroduces all that.
It basically what do they call that? What's the word I'm looking for? It basically evaporates the water off the coil by the fan continuing to run, rather than the fan turning off and the water dripping off the coil and going down the drain, because no dehumidification happens until that water drips down your drain.
Exactly.
If the coil gets cold and gets all dewy, but then the fan blows it back into the house, we haven't actually dehumidified.
Definitely.
And that can be another issue with the fan on setting. So be cautious if you're in the South with fan on. Generally don't use it. Just go to auto. If you're in the north, let's say, you're in a cold climate, okay, no big deal. Or maybe during heating season, it's not as big a deal. But little heating season we have.
But yeah, and even to that point,
you still have the envelope leakage.
Exactly.
Assuming your ductwork is out of the envelope, which we're talking about here on a remodel type situation.
Exactly.
This is kind of in the weeds, but I remember a video a couple years ago I made with a mutual friend of ours, Trey Farmer.
Yeah.
And Trey had these, I think they were IQAir branded filtration. What do you think about those? That was my next point.
Yeah. So because our air conditioner isn't running all the time, that means that we can't really rely on it for filtration. But more to the point, where these particles are and where they're being utilized, in other words, where we're breathing them in, is in the rooms. And from that perspective, having in-room air purifiers, HEPA filters in the room with us are really the best place to be able to mitigate any sources as they're coming up and also right before we breathe them. So I don't really, and that's why I recommend MERV 13 filtration at the HVAC system and not HEPA filtration or something like that. That's just going to be even more restrictive and burdensome on the AC system. Is I'm going to use HEPA filters in the rooms with us, and that's going to be really the best place for that. And we want to prioritize areas that we spend the most time. So in our bedrooms while we're sleeping, that's predominantly where we are. So we want a lot of clean air in those areas. And as I mentioned, there's no minimum amount of recommended PM 2.5 we should be breathing, and that means that really we want a HEPA filter to get all of those things out. So HEPA filtration is great. There's a bunch of different brands. IQAir is one of the brands. They're great. They're sort of medical grade technology. They have 12 pounds of carbon in their GC multigas version.
Wow, they're pretty expensive too, right?
And they are very expensive, exactly. So the 12 pounds of carbon to me is what you're paying for. Like in my opinion, HEPA filtration is great and all of their stages of filtration, awesome. But the reason why you would spend the extra money on something like that is with the GC multigas with the 12 pounds of carbon. There are also other filters out there. Only one other one that has more carbon than it, which is the Austin Air, no relation to Austin, Texas. And it has 15 pounds of carbon interactivated charcoal. And those two are sort of my go-to purifiers.
Austin Air, it's spelled like the town of Austin.
It is, yeah, but no relation. Yeah.
Okay. And it's an in-room filter?
It is, yeah. So it's an in-room HEPA filter. It's great. Both of these devices are on the expensive side and on the loud side. So keep that in mind that you're not going to be running this on high speed, and that if you would like more filtration without the noise, you may need more of these, or you may need some cheaper HEPA filtration as well, which I also recommend. But there's loads of them out there. The thing at this point, there's something I also want to say when it comes to air purifiers and air purification. You really want to avoid the gimmicks, the gadgets, the scientifically like, oh, this is the next best thing.
Stupid.
And unfortunately, those things, and believe me, my passion is indoor air quality. I have gone down the rabbit hole of every single air purifying technology out there. And if they did something great, I would be telling you about it right now. I'd just quit my job and sell those because I'm so passionate about this. But what we need to be focusing on is source control, removal technologies, not additive technologies. Yeah. So the removal of these things, right? So a HEPA filter catches. There's 3 different ways a filter works, but it basically catches or traps or entangles the particles and the mold spores and things like that are in the air. The carbon or activated charcoal does a similar thing where it absorbs the particles and odors in the VOCs to it. So both of those are removal technologies. We want to avoid any additive technologies like hydroxyl radical production, like UV lights, things like that.
Oh, I meant to ask you about that. Can we talk about UV light real quick?
Yeah. So, there's a time and a place for all of these things, and we really have to weigh what's our goals and what are our budgets to achieve those goals? And by budgets, I don't just mean cost. I mean like health budgets, right? If we are in a public space and let's say that we want to utilize some technology to try and purify the air, if we've got hundreds of people in the space and we really can't control the viral load and we don't know what's happening, then maybe we could actually literally save a few people or reduce the chances of people getting sick by utilizing these technologies. So there's a time and a place for these things. But when we're talking about in our house where we can control who is sick, what's happening, there's only 4 or 5 people in this house, we don't really need the costs outweigh the benefits of these devices. And so there's different devices out there, and we can touch on a few of them. My reason why I don't really like UV lights so much is that first off, there's particle production that happens from them. The wavelength that's needed is sometimes different than the wavelength supplied, and over time, the wavelength on these bulbs can change. And when the wavelength changes on a UV bulb, that means that it could technically now produce ozone or something like that. So it could go from a totally safe, fine, effective bulb to something that may not be so effective and actually produce something that is a very reactive chemical and harmful. At the same time as a UV light is shining on those surfaces, the UV light is only meant to surface disinfect. It's not meant to purify the air. If we wanted to purify contaminants in the air, we would have to put in an array of UV lights, and we would have to have a long contact time with the air that's going through. Right. So it's not realistic for a home to have that type of system. The next thing is...
Is it helpful, though, on the return side? Sorry, I kicked you there under the table. Is it helpful on the return side, though, to have UV light to knock down potential mold spore growth on HVAC systems? Or is that kind of bogus?
So where the UV light is shining on the supply side of the ductwork, where it's cold and wet, is technically where the mold would likely not be growing.
On the supply side, not the return side.
Right. Yeah. Where the air is cold and wet, that's where that would be. Right. If we're talking about maybe a heat pump where the coil was on the return side, sometimes I've seen mold on the return side because of the coil's proximity to the return. But mainly on the supply side is where people put it, or they put it in the coil. And the thing we have to be concerned about with UV lights is its job is to degrade organic material. And if we have a ductboard supply plenum,
it's going to degrade
it. And so, and I routinely run this, and you can see it on my Instagram, where the insulation that's in that ductboard gets all puffy, and the binders that are binding together the fiberglass are becoming airborne, right? And the fiberglass is now becoming airborne as well. And so it's not a good thing for a UV light in most situations. So
your general advice is, look, skip those.
Exactly. Unfortunately, necessary. Yes, exactly.
That's good. I appreciate that.
And again, I can go even more into the weeds with the 7 different technologies and why each one is an additive. But
I loved your general advice, which let me go back to that, which is really, let's look at source control and removal technology, not additive technology. And if I could kind of summarize a little bit, we want good filtration for HVAC systems, ideally MERV 13. Maybe if you're not sensitive, MERV 11, but the difference between 11 and 13 is almost nothing these days. What's interesting is I didn't hear you say we need to go to MERV 16 on the furnace filtration. Now you might, in some instances,
I would always like more,
okay.
But the problem is that for larger units, you need the biggest one that HEPA makes, and people just the size of putting that in, because you now have to have a transition. You can't just check a box and put it in. You have to put it in properly, which means a nice slope transition into the unit, which takes up more space. And so it's tough, again, optimized, not maximized.
I mean, to be honest, I've generally put 13 in. HEPA makes it real easy with their filter boxes to put a 13 in. But I did also hear you say, which I'm glad, because I've actually kind of come to this conclusion too, that you do like in-room source control as well.
Yes.
There's a bunch of different brands. Carrier gave me one of theirs the other several years ago that I've used in my boys' room. And it has maybe MERV 13 or so. And I'm shocked by every time I clean it how much crap is on it. And I have a very airtight, very well-built house. And I have a dog, though, that brings that junk in with him.
Yeah.
And then I have, I think, an HEPA brand in my master, and I forget whose brand in my daughter's bedroom. They've been ones that I've kind of accumulated by people giving them to me over the years. And the thing about those that I really like is they have a decent amount of airflow. They're not like these little desktop models that look like your cup on the table. Those are worthless. And they also have pretty good sized filters, and you can actually figure out filter ratings. So in general, and this is a real broad statement, but if you're looking at a model on Amazon that's $50, it's worthless. I think you need to spend between 200 and maybe 400 on a decent unit. And if you really have issues in your house, and what Sean's recommending, if you have people that are much more sensitive, move up to the carbon filtration models and just know that it's going to be a house payment. I mean, those models can be $1,000+ bucks. And a replacement cartridge, I was just looking online for that IQAir, is $250.
Right.
So these are not inexpensive units, and you probably need to replace that carbon filter. I don't know. You know,
it's every 5 years, and
that's not bad.
Yeah. So when you break it out over 5 years,
exactly.
Yeah,
that's not bad.
It's cheaper. But yeah, through my research, $180 is the lowest, most cost-effective air purifier I can find. And again, we just want HEPA filtration. We want good HEPA filtration with a good filter.
So we should look for HEPA on there.
HEPA is the most important part, and
that's like 99.9.
Yeah. So if you look at a filter chart, it's amazing to look at this chart. You can probably Google it, but basically you see you can compare all the different filtrations, and right at the PM 2.5 sort of range of size particle, all of the filters dip down like, oh, we can filter really good smaller than this, and we can filter really good higher than this. But that PM 2.5 is like a football-shaped molecule. It's particle that's hard to get through. And so the better filter is specifically to filter out that harder to get particle, which is why we have to get so tight. And so you look at all of these dips that are sort of like this, like MERV 13 has a dip that's like this. You look at a HEPA filter and it's like a blip like this at the top of the graph. And you're like, wow, HEPA is really where it's at from a filtering out the particle that is most dangerous for us. So,
and you can almost always tell too, if the replacement filter is real cheap, it's probably not very good.
Yeah.
You know, most of these models, like the one that I have in my bedroom, I want to say is maybe an HEPA. I'm not even sure if they make it anymore, but it has 3 different filters. The cheap filter that you can kind of wash or vacuum captures most of the garbage. And then it's got a stage 2 and a stage 3. And you don't need to change the stage 2 or stage 3 very often. As long as you keep up with the stage 1. I really like that style of them. And there's a bunch on the market, but just be real cautious about the, you know, $50 desktop model. It's definitely, it's that's for mental. It's for mental use, not actual use.
Yeah, so you can look at the clean air delivery rate, basically, is what you want to look for, is that models that have this CADR are going to be more legitimate than the ones that don't have this classification. So clean air delivery rate is really what you're looking for. And you know, you think, oh, I have a small room, I only need a small purifier. And it's like, well, first, you're not going to run that purifier on high speed. If you do, it's probably going to be super loud. It's also going to be sort of a drop in the ocean, like just sort of inconsequential amount of airflow coming out. You don't really even realize. So having a bigger unit that you can run on medium speed that's going to be quieter and more effective for you is really the way to go.
So that's good. Sean, super thankful to have you on the podcast, man. I appreciate you taking so much time. I told you an hour. I took 2 hours.
I know. Yeah. And really quick, quick, just to sort of summarize like the main points of what I'm saying, right, is in an existing home, we really want to do source control. We want to get rid of the mold. We want to get rid of the things that are causing the problem and just remove them. Cleaning mold is never a good thing on most materials. Most materials are porous or semi-porous, and so that includes ductwork. We don't want to be cleaning ductwork that's moldy. We don't want to be cleaning surfaces that are moldy. We want to replace those materials. And then once we do that, we obviously want to keep it dry, and we keep it dry through source control. We want to go back with resilient materials. Dehumidifying, or at least monitoring your humidity, is really important. Monitoring, that's something else we haven't really talked about, but really to understand your house and to know whether or not you may have a problem, there's a lot of monitors out there. Unfortunately, there's no monitor for mold or something like that, but you can monitor your relative humidity, you can monitor your radon levels, you can monitor PM 2.5, chemicals, VOCs. You can monitor these things just to see how things are going and if you need to make some improvements.
So good, dude.
Yeah.
How can people get a hold of you, Sean? What's the best place to look you up?
Yeah, so you can check out Instagram, IAQ Texas. You can check out our website, IAQtexas.com, and you can also just email me if you have any questions. If you've been impacted by mold, please feel free to reach out. Happy to help. That's Sean at IAQtexas.com.
And a big plug for both Positive Energy that you've worked with and for many, many years.
Yeah.
They do great jobs on HVAC design and just as important, testing services. I've used them for my blower doors and my duct blasts. And when I started testing and actually monitoring how I was doing, shockingly, I realized that I needed to get better. And it's the scorecard that we use as a builder to know how we're doing. And frankly, that saying that my buddy Jake Bruton uses all the time, trust but verify, right? We think we built a good house, but let's put a blower door on it and really see how we did. And when you do that, you find, gosh, I can get better. And let me make every house a little better has been my goal over the years. And lastly, Sean also owns the Aero Seal and Aero Barrier dealerships here in Austin, Texas, which I've used a bunch over the years, his services. Really, really thankful for you. You're a gem in the industry, my friend. Thank you for your time.
Thank you.
Guys, if you're not currently a subscriber, hit that subscribe button below. We've got new podcasts every single Friday. And would you do me a personal favor? Would you rate our podcast? Give us that 5-star if you think we deserve it. Write a little comment on how it's been helpful for you. I actually read those. And that helps more people find the Build Show podcasts. But of course, it helps us get up in the rankings, which is frankly beneficial to me. So this would be a favor that I would appreciate if you're willing to do that. With that being said, by the way, if you're listening, you can also watch the podcast over on thebuildshow.com. And we've added several podcasts to our platform. If you didn't realize it, and maybe you're not following them, we've got the Building Consensus podcast. We've got the Unbuild It podcast, and we've got Passion for Craft besides the Build Show podcast over on thebuildshow.com. So guys, follow us on Facebook or Instagram. Otherwise, we'll see you next time on the Build Show podcast.